it isn't that chemistry is about rote memorization. Like there is logic towards everything. Like some logics aren't taught to you in grade 11 and 12 and you feel that there are loopholes. Again, you must understand that chemistry is an overlapping subject with physics as well.
Welcome to GRAMOLY. I am your host Asutosh. So today we have a very special guest with us. I would like to introduce him. We have Krishna Bharadwaj with us today. He is currently an undergraduate student at IISC Bangalore. He is a KVPY SA as well as SX fellow. He has also been in the state top 1% of NSEP and NSEC. He has also qualified INCHO and has attended the OCSC camp. So thanks for being here, Krishna. It's an honor having you on GRAMOLY.
Thank you so much, Ashutosh, for the introduction. I'm a bit flattered actually, but I'm also very happy here, like talking to you guys and spreading information about Chemistry Olympiad and how science subjects work in our country.
So before starting the session, a bit about GRAMOLY. So GRAMOLY is a non-profit initiative by the students and for the students to provide free STEM content and spread awareness about pure sciences. So let's start the session. So my first question to you is, why did you enter the field of chemistry? Like what was the interest point that brought you here?
So fundamentally speaking, I used to like every science subject, that is basically physics, maths, chem, bio, everything really intrigued me. So chemistry I felt was a fundamental science in the sense that it acted as a connector between physics and mathematics and biology. Like many topics in physics overlapped with physical chemistry. Similarly, there were various applications of organic chemistry in biochemical fields. Similarly, the various things that we see around us are basically chemical structures that are explained by inorganic chemical methods. So due to all these reasons, and basically because everything that popped up in my head was answered by chemistry, I was really interested in the subject.
Okay. So how did you go about studying chemistry? As in, suppose you are starting to learn a new topic, like what was your thought process behind that?
So for chemistry, there are basically many facts in the sense that certain things or experiments have occurred and you must understand how they occurred and their various applications and their modifications. So like there are various reactions in organic chemistry and there are various inorganic compounds and their properties. And similarly speaking, there are many concepts in physical chemistry as well. So fundamentally, I would check which topic I'm looking at. Suppose it's in physical chemistry, then my aim would be basically checking the concept behind it, understanding the derivation of a particular formula, a particular concept, and keeping my concepts crystal clear would be my aim. Like I would read through the chapter, understand the concepts, try to derive the formula myself, and try to create modifications of the same thing in my head. I would try to create questions for myself. Like those are the best methods for studying that I felt. Whereas for inorganic chemistry, it's important that you have a well-established textbook because like there are facts. So your facts must be correct. So I had referred various books for that as well. And for organic chemistry, again, there are various reactions and their mechanisms, etc. You can't remember everything, right? But you have to keep your concepts clear. You must understand how a particular thing has occurred, how a reaction proceeds, why a particular step has occurred. So understanding the bare basics was what was most important. After doing that, I would like practice questions from various books or create questions for myself.
Okay, cool. So the next question is, as we can see from your LinkedIn profile, you have got a very good rank in JEE Advanced. So what is the difference between the level of questions that are asked in JEE and Olympiads?
So first, let me talk about JEE Mains. So the questions over there are pretty straightforward. There is a well-described syllabus. You must know the topics present there. You must read the NCERT books carefully and simply answer those questions. They aren't that twisted. You don't need really clear concepts for solving those problems. All that you need to do is read the NCERT thoroughly, mug up the statements, and that makes the exam pretty boring, I would say, from a chemistry perspective. Whereas for JEE Advanced, the physical chemistry questions are again based on concept applications. But since they don't allow a calculator in the exam hall, there is a lot of calculations that you must do on your own. So rather than testing your concepts completely, there is a thing that your calculations must be perfect. So they're checking your peace of mind as well at that same time. The questions aren't that tough. If you know the formulae, the basic things about it, you can solve them. And speaking about inorganic and organic, they basically rely on a certain set of problems, types of problems, or a certain set of reactions. So all you must do is understand those mechanisms and their modifications, what that could be possible, and you'll be able to solve all the problems. Whereas coming to the Olympiads, let's talk about NSEC first. So the question quality is again similar to JEE Advanced, just that there is a slightly broader syllabus. So if you're well and thorough with your JEE Advanced preparation, you can easily crack NSEC and vice versa as well. Just that you must practice the past year problems to exactly understand the syllabus very well. And the questions are of single correct or multi-correct type, so it makes it easier than JEE Advanced. But again, there is a time constraint. Now, lastly, let's talk about INCH. So again, here the problems are subjective type, paragraph based, and they're going to test your patience and concept. Most of the questions won't be of a type that you've seen before or earlier. So it's better that you don't get flustered during the exam hall looking at those questions. What you must do is understand what is given in the particular question, use your carefully basics, whatever you have learned earlier, and try to apply them. And you must know that there are hints in every problem to solve. So if you identify those hints, you'll be able to solve every problem that is given in the INCH paper. Again, the time constraint makes it really impossible to solve every question correctly, but the cutoffs are low as well. So for INCHO, your main aim must be to understand concepts carefully, especially for physical and organic chemistry. And the syllabus is again very wide over there. It's not as well prescribed as JEE Advanced. So you must look at the previous year problems and check out those problems that you weren't able to do in them, and then look up those solutions, and maybe they'll lead you to some research papers, etc. Read them up, and that will enhance your concept basically towards the subject.
Okay, that answers the most, preparation part for Olympiads. So, as you have attended the OCSC camp also, you must have met other students too who were just as good as you in chemistry. So, what do you think the most common quality among all of them?
Most of the students who were there were either better than me or as good as me. They're really good students. So one common quality that I saw in those students is that they actually read a book or read about a particular subject because they were really interested in them. And their concepts were really crystal clear. Like if you give them a new problem that you have never encountered, they'll still be able to solve them because fundamentally they have read books, they know the subject, they're really interested in it, and they have crystal clear concepts. And they're adaptive basically. They can adapt to a new question because their concepts are clear.
Okay. So, can you share any, experience, some out of the box experience at OCSC camp, something that you have encountered?
Yeah, the profs were really cool there. They were really interested in teaching us. And I remember a particular incident where there was a thermodynamics prof from IIT Bombay, and he had taught us a part, and there was a question regarding chemical equilibrium, which was not a part of the course. And then he took up an extra lecture after the whole day to teach us that concept. So that was really nice from his part.
Oh, cool. So the next question is, what is your ambition? Do you want to go to research or go into an MNC, or is it too early to say?
For now, at least I can say that I am really interested in chemistry and biology and maybe some topics of physics as well. So, but I am pretty sure I want to do research as well. Whether I want to get into academia or industry is another thing that I'll decide later. But for now, my main aim is to look at every single subject that is at my hand and to understand what really interests me. Like which domain of a particular subject is what I'm interested in. And then I'll choose my career path. But I am 100% sure that I want to get into research. Research in academia or industry is what I'll decide later. There is a lot of scope everywhere. So.
Yeah. So we also see that you like biochemistry and chemical biology, even though you took PCM in 11th and 12th. So how did this love for the culmination of biology and chemistry, come together?
If I'm being truly honest, I used to hate chemistry in grade 10 and even biology. I would never get any good grades in them as well. But the thing is, I wouldn't study them properly. So when I looked into some foreign author textbooks, started reading them because at the end of the day, when I was in the beginning of grade 11, all I wanted to do was write JEE and get into some IIT and do something related to engineering. But for doing that, again, you have to do chemistry, right? So I had dropped biology since I had no interest in it. But when I started reading chemistry textbooks, I fell in love with the subject. So I kept on reading and reading and reading, and then I became really interested in it. And when I was preparing for KVPY in grade 11, I had to read biology for that. So while reading biology from the NCERT book itself, I started liking the subject. The basic thing is how chemical principles can be applied to biological systems, and how everything in this world that is biological is basically a chemical framework that follows intricate biological rules is what is really interesting to me. Like everything is basically chemistry, but arranged in a beautiful way that makes it biology. So that's what really made me interested in the subject. And then I went on to pursue it in grade 12, where I read more about it and became really interested in it. And even now, when I'm in IISC, biology is really different from what it was in grade 11 and 12, but it is really interesting again, I would say.
Oh, okay. So, can you recall any incident where you saw chemistry or biology solve a real world problem in your daily life?
Solving a real world problem, like there are things that occur every day that solve real world problems. I haven't seen anything in my eyes that has solved a real world problem completely. Possibly in near future, I'll see something like that. But I did try to do certain experiments at home, like clock reactions and toothpaste experiments and trying to burn stuff and seeing color changes and stuff. So that was really interesting. I had also tried once to separate iodine crystals from iodine tincture. The quick color changes and physical changes that you see live in front of your eyes really made it very appealing for me. Actually. Like I was really interested in seeing those chemical changes occur quickly. So
yeah,
those are some real life experiences.
Yeah,
basically.
chemistry is basically it gives a sense of gratification as you could see the reaction happen, right?
Like the color changes and the time lapse of a particular reaction is very interesting.
Yeah.
Most of the science labs, etc., those YouTube channels also have chemistry only, right? So,
yes. So, has university chemistry turned out what you expected in IISc Bangalore?
To a great extent, yes. The thing is that I have only completed my first semester, so I've been exposed to physical chemistry only. But in the next few semesters, there will be inorganic and organic chemistry, and I'm really excited to see how it turns out to be. But for the physical chemistry part, yes, I'm sure that it was much different than what we had done in JEE, in the sense that during my grade 11 and 12, the main focus would be solving problems, like how you arrive at them, what you do to get them is not important. But here, like, you have to be crystal clear about every statement that is written in the book or whatever the prof teaches. And how to apply them will be really different in the sense that they aren't standard problems. What you learn is not necessarily what you'll do in the examination paper or when you discuss with the prof. He'll give you something else and you'll have to apply your brain sitting there and understand the basic concept. Even the assignments that they give you are out of the box. Like you'll spend a lot of time thinking about how to get those solutions. So it's basically a lot of brainstorming and modeling when you're solving assignments or papers.
Okay. I think the course might be so hectic in IISc Bangalore, being one of the most prestigious colleges in the world. Is it so?
Yeah, it's really hectic. Like you'll have to do physics, chem, bio, math, and engineering as well, along with humanities. And there will be labs for every subject. And basically, it is really hectic.
Oh.
Like if you're ready that you want to do pure science, you're really interested in the subject, then this is really a good place because the peer group is excellent here. The profs are also really good and there are great research opportunities. But if you want to like stay chill and do what you want and stuff like that, then here the course load is very hectic. There's a lot of things that you have to do in a particular day. A lot of assignments, lab tasks, lab reports and things like that. So there will be a lot of work.
Oh, okay. So this is a very important question that many of us students are dealing with. So how do you deal with stress and inadequacy in your student life?
So fundamentally, the basic thing is that never allow yourself to get stressed. So that's like a random statement. Like it's very difficult to do, but there are certain things that I did to reduce stress when I used to study. Fundamentally, you must understand that studying for an exam is very different from studying for fun. When you're studying for fun, you're studying something you like. At that time, you aren't stressed at all because it's like reading a novel, right? So while you be stressed. But if you're studying for an exam, there must be a plan basically. What you want to execute in a particular day, because the number of days from a particular day to the exam date is limited. And the number of tasks are defined. So you must plan yourself accordingly. So what you can do is decide tasks for yourself in a particular day. Like the number of hours is random. Like it's not necessary that you must study these many hours in a day to succeed or something, but you must complete your tasks. The tasks must be realistic. Like how many hours you take to do a task is immaterial. You may take 2 hours or you may take 10 hours. But at the end of the day, if you've completed your task, then you're mentally satisfied when you go to sleep. Sleep is again very important. Like don't kill your sleep in order to study unless there is something really important. Like especially in grade 11, 12, it's not really required. You don't need to kill your sleep. We can do that later on. So that is one thing. Another thing, there can be backlogs, no doubt. One day you fall sick, or one day there was some family function or something, and you weren't able to complete the task for that day. So rather than cramming everything up for the next day, what you could do is split that day's task into smaller chunks, and then add those smaller chunks into 1 week's time. So what that does is slightly increases your task per day, and your backlogs get ended in a week's time. So that is one thing. It's really important. Like don't allow backlogs to build, but if they're built, like solve them quickly in 1 week's time. Don't allow them to pile up. So if you don't have backlogs, there won't be any stress. I'm sure about that.
So coming to the backlog question, so how did you manage your preparation of JEE along with Olympiads during 11-12?
So I spent a lot of time doing chemistry. So that chemistry, if you study for Olympiad, you have already covered topics for JEE. Like what you must understand is you must do your task at hand. If there is a JEE exam coming up, the month you have to spend doing on JEE. If there is an Olympiad coming up, you have to spend the time before that doing Olympiads. If you're interested in it, again, it's not necessary that you must do. So that's what I did. Another thing is that never lose touch in a particular subject. Even though I'm preparing for Chemistry Olympiad, I won't stop studying physics or math or solving problems at least. Even if you're not able to study a new topic, just solve problems or revise stuff so that everything that you've studied is in your memory. And during JEE, for preparing for Olympiads, mainly just study those JEE topics from books that are advanced, basically. So that will give you clarity for your JEE exam as well. And if you're preparing for an Olympiad, you're basically trying to master one particular subject. That is trying to master 1/3 of your JEE exams. So if you have mastered 1/3 of your JEE exam, after the Olympiad, the effort that you must put in that subject is reduced to zilch. You must do the other 2 subjects at that time. So that's what I did. Like before the Chemistry Olympiad exam, I would focus on chemistry a long time. I wouldn't leave physics and maths. After the Olympiad was over, I was pretty confident about my chemistry and I spent little time on that and did large amount of physics and maths. But again, I didn't leave chemistry. Never be overconfident again. Even if you know something, keep revising so that you don't forget it. Or just solve problems to revise.
So what last minute tips do you like to give to the students who are preparing for IOQC, as it is coming very near? In the next month IOQC will be conducted. So yeah, the second question is, how can revision be done efficiently?
Okay, so fundamentally most important thing for IOQC is you understand your preparation level at this point. Like, have you prepared for NSEC or are you ready to give INCHO? If you have not done anything for INCHO, you're not sure, then I would say you focus on NSEC only. Like even if you qualify that exam, it is a great boost for your JEE exams as well. It's a great morale boost. Since there are only 300 to 400 students who are going to qualify NSEC, you'll be in top those students. But for your INCHO, about 50 or 30 students will be selected. So that is again very, very difficult because there will be students who have studied much more than you. No doubt about that. So if you're well prepared for NSEC, then you can focus on INCHO. If you're not prepared for NSEC, do the past year problems for NSEC. They will help you in JEE Mains and Advanced as well. Solve the past year problems, look at those problems that you are unable to solve, find the solutions for them, and that's how the learning process is going to continue. But if you have thorough with your NSEC preparation, then just time yourself, give 1 or 2 papers, and try to complete the paper of NSCC in 3/4 the time. Because exam scenario is again always different from your home scenario or your whatever scenario in which you're giving the exam. So try to complete the paper in 3/4 time so that you're prepared to give the exam in 1 hour time if it's there. And for INCHO, the past year problems are again the key. You must time yourself. Suppose the exam is from 2 to 5. You're giving the past year paper in that particular slot only. And after 5, you're going to look at the solutions. You're going to time yourself, look at the solutions, see how many marks you got, see the cutoff for that particular year, check if you're qualifying or not. If you're qualifying, then your preparation is going well. If you're not qualifying, then don't lose your morale. Like, there is still time, right? You can improve yourself. So look at those problems you're unable to solve. Why weren't you unable to solve them? Was it a conceptual error? Was it an error of judgment? Was it a calculation error or a silly mistake? Look at that. There will be many problems you'll be unable to solve completely. Simply go to that problem, search it on the internet, look about it in a particular book, check out its solution. If you get a research paper, read it, understand it, and your concept will be clear. And during the next exam, your confidence will increase. Because the exam is of such nature that if you're going to give it, then there will be problems that you've never tackled before. But what you can do is solve as many problems as you can so that there is a slight chance that there is some problem you've seen earlier. So that could be your strategy. Time yourself, solve it subjectively. Since you're giving JEE, you're used to objective problems. So you must accustom yourself to giving a subjective paper. Check out how they're marking it. Check out if your answers are fitting in the particular box that is given. And see where you have gone wrong. And then re-revise and revise. For revision, what I did was created a small list of formulae and concepts that I would read every day, 1 hour maybe, just revising everything. And that's it basically. Read the mechanisms every day, small short notes that you would revise every day. And while making those short notes is also again a revision for yourself. Making short notes is also a revision. Reading them is also a revision. And slowly you will remember in which page what reaction is there. And that's going to help you in JEE as well. No doubt about that.
So coming to the revision part of what you said, so as we can see, Olympiads have a there's not really a boundary for the syllabus. So how can students not go over the syllabus and perform better in Olympiads?
The thing is again the same. Check out the past year papers. There is a trend. I am sure about it. You'll have to see the past year papers. The topics are from everything that is in your NCERT textbook 11-12. But they are at a higher level. So I would like to suggest some books. Like for organic chemistry, I read L.G. Wade, which was a base book. Like if you're preparing for next year, you can start it now. Like it's written in a very lucid manner, the whole book. It will develop your interest in that subject. You'll be really enthusiastic to read that book if you've started it once. And then you can move on to Peter Sykes and Claydon, which have a large amount of reactions. So what you can do is read them, understand the mechanisms. So the more the mechanisms you read randomly, the more that you understand the various concepts involved in that. And when you're given a new problem, your brain will start working as to what could be the new reaction mechanism for that given reagent and reaction set. Understand the reaction set, the reagent set. What you could do if that reagent was there. Look at its nature and try to recall things that you have learned earlier. For inorganic chemistry, I had read J.D. Lee mainly. And for organometallic chemistry and for coordination compounds and metallurgy, I had done basically Shriver-Atkins. And there were some problems for which I had referred Huey. That is another inorganic book. For qualitative analysis, if you have any doubt in the J.D. Lee part or somewhere else, you could check out Vogel's qualitative analysis book, which is again a good book. For physical chemistry, just to Peter Atkins. It's a really good book. Don't do the problems, just read through the book. Your concepts will be clear, I'm sure about that. Understand the graphs, how to plot a particular graph, why is the graph having a particular nature. And the other skill sets for Olympiad are basically your analysis skills. If you're given a new problem, how to analyze it, you must understand that.
So how did you prepare for the qualitative analysis section? As there's a lot of things that are needed to be remembered.
Yeah, there is a lot of things, and what you could do is there are some principles like HSAB principles or looking at the nature of the reactants involved that you could actually hypothesize whether it is a precipitate or it's going to be in a aqueous form or something. So you could look at that, try to hypothesize yourself. If you go wrong, then you can always correct yourself. One thing that I saw is that you tend to remember things that you have done incorrectly rather than the things that you know. So try to solve problems. So if you're solving problems, then if you go wrong somewhere, you're obviously going to remember it. And if you're right, that means you remember it. So that is one strategy that you could do. Just make short notes. For colors, I did not really use any trick or something. I would there is rote memorization again that you could do. Rote memorization every day helps possibly because over a week's time, you're going to remember the same thing every day. So possibly before the exam, there is a high probability you'll remember it. Don't do last minute cramming. You won't remember anything that day. Do a 1 week's planned schedule. You learned 5 reactions on the first day. On the next day, you do 5 new reactions and revise the 5 old reactions. On the third day, and it's a cumulative process. So that's one thing I did.
So what would be your advice for someone who is preparing for INCHO in their 10th or 11th standard?
Just follow the books and do the past year problems. If you have any doubt in a particular problem, ask some senior or some prof, he'll help you out. Keep your concepts clear. Don't mug up formulae, don't mug up reactions, don't mug up mechanisms. Understand them, enjoy them, read them properly, and you will enjoy the subject. I am sure about that. Don't think of it as an exam. You pass or fail is a different thing. But what you must understand is you're enjoying the subject. That is most important.
Okay. So what do you think, the myth that you have occurred in your chemistry career that you want to debunk, that common people, एक myth बना हुआ है सबके mind में chemistry के बारे में. So what do you want to debunk about that?
It isn't that chemistry is about rote memorization. There is logic towards everything. Some logics aren't taught to you in grade 11 and 12 and you feel that there are loopholes. Again, you must understand that chemistry is an overlapping subject with physics as well. So if loopholes exist in chemistry, they are in physics as well. It's not like chemistry is filled with loopholes and all the other subjects are fine. Chemistry isn't about rote memorization. There is a logic towards everything that is present. If you understand the logic, then you're going to enjoy the subject. But you have to try to understand the logic. That is the thing. People don't try. They assume that it's about memorization and they leave it.
Okay. So now I want to deviate the discussion about books. So coming to organic chemistry, do you think Claydon is a very comprehensive book? Should students prepare for all of what it is in Claydon?
Not really, I would say. It is a really big and fat book and probably you'll be bored in doing it. It's a well-written book, but it's not that well-written that a first-timer can enjoy reading the book and develop interest. That is why I would suggest reading L.G. Wade as a book. It's written in a very simple manner. There aren't too many reactions, but there aren't too less reactions. But it's written in a way that will develop your interest towards the subject. After reading Wade, I'm sure 60 to 70% of your concepts should be crystal clear. You could go about solving problems from some book or create problems yourself. Try to hypothesize the solutions, then check in the net if that is the solution given, something like that. Then you can go about reading selective chapters from Claydon, from those topics that have been asked earlier in INCH. There are some topics like heteroatoms in aromatic cycles, like pyrrole and those reactions, etc. They aren't given in LG Wade or in Peter Sykes, but they are given in Claydon. You could read that chapter out. Similarly, all those contents that have been asked in INCHO and are not in LG Wade are those things that you could do from Claydon. Peter Sykes is a short book, very small book. You can finish it in about a month's time max, where you could really learn the various yields and percentages, which gives a lot of sense to the experimental methods in organic chemistry and again to the reaction mechanisms of the various reactions present. So you could do Peter Sykes as well. It's not necessary that you learn Claydon from zero because it involves a lot of MOT concepts which students haven't been introduced initially in grade 10 and 11. So LG Wade does not have all those complicated stuff. It is a very simple book and really nice that I would recommend.
So as you might have experienced in your around you, in organic chemistry often wrong concepts are being formed by seeing some weird mechanisms. Students get weirded out by ये सब क्या पढ़ना है, it's so complex. So what do you suggest about that?
See, at the end of the day, what is a chemical reaction? An organic reaction. At every step, there is a rule basically, and there is a logic to a rule. what is occurring is a negatively charged thing is attacking a positively charged thing due to a particular affinity. It is a very simple thing. Why does a water molecule attack a carbonyl position sometimes? Because water has oxygen, which has a lone pair, a negative charge, and the carbonyl carbon has a positive charge. So there is an electrostatic attraction, hypothetically possible. Another thing you must understand is that experimental things came first. Like a particular reaction first occurred in the lab. And to understand why that occurred, there is a plausible mechanism that was proposed. So that is another thing that you must understand. It's not that a mechanism was proposed and then randomly that reaction occurred in the lab as well. Mechanisms were created in order to justify the reactions that you observed. So complex stuff is, again, you have to break down into simpler steps. You must understand every step, why it occurred. If you have answers to every step, then you have the answer to the whole reaction itself. So that's how you must understand it. Solve it in bits and pieces.
So coming to the INCHO questions, so what do you recommend the students who are preparing for INCHO to do in their last 10 days before the exam and on their exam day?
So for the last 10 days, what I would recommend is, like, if you have solved every past year paper, then don't do anything more. Just revise your concepts, revise those problems that you were unable to solve earlier. So that is one thing. If you have not solved every past year paper, don't go about spending every 10 day solving every 10 paper of the last 10 years, because that would exhaust your brain. So go about solving 2 or 3 papers of the last 3 recent years. Look at those things that you are unable to solve and just revise your concepts thoroughly. That is most important. On the exam day, your presence of mind is most important. Don't get flustered in the exam, because every problem that you see might not be something that you've done earlier. But you must have confidence in your method and your step. And you must understand that you know the subject, and that's why you're going in a particular direction in solving the problem. There are hints in every step. You must identify them. If you identify a particular hint, then you're done. And again, if there is a time constraint, like you're unable to solve every question, it's not necessary that you solve it. You must pick and choose. Like the cutoffs aren't really high because the paper is tough generally and there is a time constraint. So what you must do is basically look at certain problems. Like if there are 6 problems generally, then solve 4. You're confident about the 4, then just check them out. And if there's time, solve the 5th one. And if you have time, solve every 6 problem. So you must pick and choose as to which problem you must solve.
Yeah. So how was your exam day experience was like?
So my experience was pretty bad.
Oh.
In the sense that I couldn't satisfactorily complete my NSCC paper, and the teacher had given the INCHA paper 15 minutes late. So I felt that I had done really badly because I did not get sufficient time to solve the paper. But there were 2 concepts that I had learned earlier and they had arrived in the exam. So I was really happy on seeing that something was repeated and I had done it earlier. So that boosted my morale. Again, I left one question completely because I wasn't sure about it, but I solved the others properly. So I was sure about those ones.
Okay. So what do you feel about chapters like ionic equilibrium, which students think is the toughest chapter in physical chemistry? So due to a lot of formulas, calculation and derivations.
Again, don't remember a single formula. Just understand the concept as to what is occurring. Like you could link ionic equilibrium with chemical equilibrium and thermodynamics also. Everything is basically ionic equilibrium, that is chemical equilibrium, if it is in aqueous medium. Like there are protons and hydroxyl ions moving everywhere. So what you must do is understand the derivations and what approximation are you doing in order to arrive to that conclusive formula that is present. What are those approximations that you're taking and why are you taking those approximations? Because there are various formulae that are not applicable everywhere. But you must understand the core concept. Like you must understand the core concept and try to derive every possible formula on your own. That is the most important thing for ionic equilibrium. You don't need to remember every formula, but you must understand that which formula is applicable where and why was that formula arrived from the fundamental formula. What were the approximations used? Why were the approximations used? That is the most important thing.
Okay. So now let us take some audience questions also from the live chat. So Debadrito Roy has asked this question. So can you talk about some calculation tricks for JE, as it is very difficult for me? This is what he asked.
So for calculation tricks, basically, like there aren't really many, but you have to try to do them quickly. Practice them basically. Remember the short forms of the basic logs, log 3, etc. You can try to remember them and try to take approximations if there are options. Basically, like if the options are well scattered, like there is something 30 and a 3 and a 300 and a 25. So you can try to arrive to one of them by taking small approximation, like taking 3.2 as 3 and then plugging it in there and then trying to get your answer or something like that. You could do that.
Okay. So the next question is asked by Kishan. So how do we remember exceptions in inorganic chemistry?
There is nothing called an exception. It's just a different phenomena. So there is an explanation for that phenomena. Everything is a phenomena. There is an explanation for everything. So never treat it as an exception. It's again just another phenomena, another concept. And remembering them is there is a deviation. Why the deviation occurred is what's more important, rather than remembering or marking it up. That will clear your concepts regarding the original thing as well.
Okay. So the next question is asked by Euler. So can you talk about how you got to INCHO in class 11th itself?
I had qualified in grade 12 actually. I did not qualify in grade 11. I hadn't finished my whole syllabus for INCHO. I had qualified, like I had done really well in the NSCC, but again, the thing is that if you haven't completed your syllabus, it's very difficult. I was exposed to it really late, like I got to know about it in mid 11th, so I couldn't prepare. But during grade 12, I was inclined towards INCHO and therefore had prepared really well for it. But if you are a grade 11 aspirant, then again, if you follow the books that I had said from a little bit earlier than the beginning of grade 11, you can also, it's not impossible. There are many people who have done that.
Okay, so that's it for today, I guess. So thank you for bringing here, Krishna. It was an honor having you on GRAMOLY. So
Thank you so much, Asutosh. It was really nice interacting with you.
Yes. So thank you guys for joining. See you soon.